Hi, this is John Linneball with John Linneball Tutoring, and this is Barron's SAT Premium Study Guide, Chapter 6J, Triangles. For the best results, I suggest you use Barron's SAT 30th, 29th, or even the 28th edition. This video covers pages 574 through 576 in the 30th edition of Barron's SAT, which is also called the Premium SAT Study Guide. The page numbers are the same in the 29th edition, and they're identical or close enough in the 28th and previous editions. You shouldn't use an edition older than Barron's new SAT from 2016 in any event. Not everything in the book is in these questions. Please do read the books. Chapter 6 and even Chapter 5 are really good resources for SAT prep in the math, and the rest of the book is great for the rest of the SAT. The older editions of this book can be had cheaply, if not for free, from used booksellers, kids who've already taken the test, in public libraries. They sell old editions, or you can borrow the current edition. If you plan to use a library copy or a new edition, I suggest you start early. There's no worse feeling than needing a library book someone else has checked out, or trying to buy a review book that's sold out. So, let's get started. Problem 1, page 574. In the triangle in the figure, and here's the figure from the book, what is the value of x? Well, this should be pretty easy. We have 30 plus 2x plus x. So 30 plus 2x plus x equals 30 plus 3x, we just combine like terms, equals 180. So then we subtract 30 from each side, get 3x equals 150. So x is equal to 50, which is choice C. Problem 2, page 574. What is the area of an equilateral triangle whose altitude is 6? Well, we draw a little altitude. You can pretend there's a little box there to tell you that it's a right angle. But you should know an altitude is always at a right angle with the base of a triangle. So, the first thing we should do is draw a diagram. An equilateral triangle has three 60-degree angles. The altitude divides the equilateral triangle into two 30, 60, 90 triangles, so we know these are 60. We know these ones at the top are both 30, and this, of course, is 90 in the middle. So, the 30, 60, 90 triangle side ratios, which you really should know, this is 1, the short leg. The longer leg is going to be square root of 3, and the hypotenuse is 2. So since this altitude is 6, then we know that this short leg here, which is half the base, is going to be 6 divided by square root of 3. So we can rationalize the denominator, which just means you multiply by root 3 divided by root 3, and you get 6 root 3 divided by root 3 squared, which is of course 3. So we know that the area of a triangle is 1/2 times base times height. So 6 root 3 is half the base, 6 is the height. So we can just factor out the 1/2 and just go 6 root 3 over 3 times 6, which is 3 times 2. It's always good to factor it, so this 3 and this 3 that came from the 6, 3 times 2, remember, those cancel out, so you get 6 times 2 times root 3, which of course is 12 root 3, which is choice B. Problem 3, page 574. Two sides of a right triangle are 12 and 13. Which of the following could be the length of the third side? Alright, well, we have number 1, 5. Well, number 1, we know a 5, 12, 13 triangle is a classic Pythagorean triple. If you don't know that, you can just use the Pythagorean theorem. So 13 squared is 169, 12 squared is 144, 5 squared is 25. Those would also be good things to memorize for the SAT. Probably all of your squares between 1 and 20. So anyway, we know 144 plus 25 is equal to 169, so we know 1 is true. And just remember 5, 12, 13, classic Pythagorean triple. If you know the legs are 5 and 12, the hypotenuse has to be 13. If the hypotenuse is 13 and one of the sides is 12, the other one's 5, and so on. Number 2, 11 squared is 121, and 11 and 12 would have to be the legs, because 13 would be the longest. Well, 121, which is 11 squared, plus 144 is 265, and that's not 169, so 2 must be false because it violates the theorem. Now, 3. 12 squared, 144, plus 169, which we know is 13 squared, equals 313, so 12 squared plus 13 squared is 313, and the hypotenuse would be the square root of 313, so 3 is true. So 1 and 3, choice C, is correct. Problem 4, number 574. What is the smallest integer x for which x plus 5, and 2x minus 15 can be the length of a triangle? We know the sum of the two sides of any triangle must be longer than the third side. Otherwise, we'd end up with something like this. If you have the two shorter legs are not as long as two shorter sides add up to something shorter than the longest side, you're just going to have a short line on top of a longer line. That's not going to make a triangle. If you try to make a triangle, then you're going to end up with something like this, some open figure that's not closed, so it's not a polygon. It's definitely not a triangle. So the angles make the sides have to be longer than if the sides were just laid with the two shorter ones lined up against the shorter side. In other words, because it bends like this, this has to be longer. Makes perfect sense. Walking from here to here would take less time than walking from here to here, right? So, okay. The algebraic solution, you can go x plus 5 is greater than 2x minus 15 because 5 is greater than negative 15. You subtract 2x from each side and you end up with this thing that's always true. However, since it's always true, that's not particularly helpful since it's going to be true no matter what the value of x is. So let's try something else. X plus 2x minus 15 has to be greater than x plus 5. So then we combine like terms. 3x minus 15 is greater than x plus 5. And then, okay, so we add 15 to each side. So 3x is greater than x plus 20. Then we subtract x from each side. So we get 2x is greater than 20. And x has to be greater than 10. Since they tell you that x is an integer, it has to be the next integer bigger than 10, which of course is 11. So, as I say, 2x is greater than 20, x is greater than 10, so the answer has to be 11 since it has to be an integer. The answer is choice D. You may find it easier just to substitute the answer choices into the problem until you find one that works. Let's try choice C, which is 10. The sides are then 10, 15, and 5. 5 plus 10 is 15, so a triangle with those side lines would just be two lines on top of one line or an open figure as listed above. So, choice D, 11, gives us 11, 16, and 7, so 11 plus 7 is 18, which is greater than 16, so that works. Also notice that 7 is greater than 16 minus 11, so the other triangle inequality, that is the shortest side must be greater than the difference of the two other sides, also work. Alright, problem 5, page 574. What is the value of x in the figure shown? Well, we see it's an isosceles triangle because we have two sides that are both marked 45 units, whatever unit they're using. And the angle between them is 45 degrees. So we know that this angle here is across from a 45. This one is also across from a 45. So we know this angle here, next to my little scratch out, has to be equal to this angle here. So we have this angle's 45. So since they're opposite, the two sides are opposite equal angles, it means if the angles measure as y, 2y is equal to 180 minus 45, which is 135. Therefore, y has to be 135 over 2, which is 67.5, as I wrote here in my book. So x is going to be 180 minus 67.5, which is 112.5. Now, if I had the measure of both of these angles, which I didn't, then x would be equal to the measure of this angle plus this angle, because this and x have to add up to 180, and obviously this, and this also have to add up to 180. So since this is, x is 180 minus this angle, and these two would also be 180 minus this angle, they would be the same. But couldn't do that easily here without figuring out the 67.5, in which case it'd be kind of silly to do that. So, let's go on to the next one. Problem 6. What is the value of PS in the triangle? Well, we know that this is 5, we know that this is 11, and we know that that's 20, and we know it's a right triangle. This is obviously the hypotenuse, the side across from the right angle, it's the longest side. So 20 squared is 400. And 11 plus 5 is 16, so 20 squared is equal to 16 squared plus PQ squared. So that's going to be 400 minus 256 equals 144, which we know is 12 squared. So PQ is 12. Are we done? No, because they're asking for PS. So we see 5, we see 12. Ah, it's a Pythagorean triplet. So we just know that's 13. Boom, we're done. If you don't know that, 13 is choice D. If you don't know that, you can just use the Pythagorean theorem. Take 12 squared, which is 144, plus 5 squared, which is 25. Get 169, and if it's on the calculator section, you can just take the square root using your calculator. If not, hopefully you'll remember that 169 is 13 squared. And it probably wouldn't take you that long to guess it if worse came to worse. But anyway, the answer is choice D, which is 13. Problem 7. Okay, 7 and 8 refer to the following figure. We see we have a rectangle, and they tell you ABCD is a rectangle. So, what is the area of triangle BED? Well, here's BED. Oh, it's one of those shaded problems. Okay, so what you do with things like that is you figure out the area of the entire figure, which is easy. It's 5, here's 4, here's 5, so this side is 9, which means this opposite side is also 9. This is 12, which means this is 12. So you just multiply 12 times 9. Easy enough, you just get 108. So it's 108, and then we have to subtract this versus this. Well, all right. DEC, that's just going to be 1/2 5 times 12. Okay, 1/2 of 12 is 6. 6 times 5 is 30. Notice I didn't even have to touch a calculator to figure that out. The next one, okay, DAB. Well, I know that's 9, I know that's 12. Okay, 1/2 of 12 is 6. 6 times 9 is 54. So then we have 54, we have 30. So then add those together, we get 84. So we have to subtract that from 108. 108 minus 84 is equal to 24, which is choice B. Problem 8, page 575. What is the perimeter of BED? Well, okay, again, we can use the Pythagorean theorem. 9 squared is 81, 12 squared is 144. Add them together, you get 225. Square root of 225 is 15. If it's on the calculator section, you can just figure that out using your calculator. If not, hopefully you'll know what 15 squared is, and you'll just be able to go, boom, I know 225 is 15 squared. Don't even have to touch a calculator. Otherwise, you might have to play around with a little bit until you get the right number. Anyway, so the perimeter is going to be 15 plus 4 plus 13, which sums up to 32, which is choice C. Problem 9, page 575. Sorry, I had to take pictures of my book at kind of a funky angle here, so it's a little curved, but anyway. Alright, so what is the area of DFH? Again, same issue here. We see that it's a rectangle with sides 7 and 3, so we know the whole rectangle is 21. And then we can see this is 3. We know the hypotenuse is 5 because we know it's a right triangle because they tell you, and it's a rectangle. So 3, if you see the hypotenuse is 5, one of the sides is 3, you should automatically know it's the 3, 4, 5 triangle. If not, again, 5 squared is 25, subtract 3 squared, which is 9. You get 16, which is, of course, 4 squared. So then the next one is going to be 7 times 3 divided by 2. Okay, that's 21 divided by 2, so that's 10.5. So you can see here 7 times 3 is 21. The area is going to be half of 21, which is 10.5. So then this other one, as I already told you, well, we know it's 3, 4, 5, so it's going to be 1/2. 3 times 4. 1/2 of 4 is 2. 2 times 3 is 6. So we just add 6 to 10.5, we get 16.5, so then you subtract 10.5 and 6, which is 16.5 from 21, to get 4.5, which is choice B. Alright, problem 10, page 576. What is the perimeter of DFH? Well, alright, we already know that this is 5, and since this is 7 and this is 4, it's a rectangle, so these sides have to be the same. GF has to be the same length as DE. You know HF is equal to 3. That's super easy. And we know this is 5, so 3 plus 5 is 8. And then we need to use the Pythagorean theorem. Okay, 7 squared is 49. 3 squared is 9. 49 plus 9 is 58. So this has to be the square root of 58. Remember, a squared plus b squared equals c squared. So the perimeter is going to be 8 plus root 58, which is choice B. And okay. So problem 11. Questions 11 and 12 refer to the following figure, well, the figure that I've taken a picture of here. You can see I already scrawled my notes all over it, so you can pretend that anything that's obviously written in pen doesn't exist if you want. Anyway, what is the perimeter of triangle ABC? Well, alright, we know one side is 10, we know part of it is 6, but we don't know this and we don't know that. So the first thing you see, 6 and 10, alright, so you can use the Pythagorean theorem. 10 squared is 100 minus 6 squared, that's 100 minus 36, that's 64. You should instantly know that that's 8. You can also notice this is just a 3, 4, 5 triangle where all the sides are multiplied by 2. 3 times 2 is 6, 2 times 5 is 10, and 2 times 4 is 8. So either way, it shouldn't take you too long to figure out that this is 8 here, this line segment AD. So once you know that, then it's pretty easy to see, okay, if this is a 30-degree angle and this is a 90-degree angle, this has to be 60. Hey, it's 30, 60, 90. It's almost like it's a contrived SAT problem. So then you're going to say, this is 8. All right, this has to be 2 times 8 because it's 16. And the shorter leg has to be 8 times root 3. So then you just go, okay, well, that's 10 plus 6 is 16, plus 16 is 32, and then plus 8 root 3. So that's the answer we get, is it's 10 plus 16 plus 6 is plus 8 plus 3 is 32 plus 8 root 3, which is choice C. Problem 12, what's the area of ABC? Okay, warning, this is not a 30, 60, 90 triangle. I know it looks close and it's not terribly far off, but it's not. So you can't just go, oh, all right, well, I know this is 10 and I know this is 16, so then I'll multiply 16 by the 1/2, and so that'll be 8, and then 8 times 10 is 80. You can't do that. It's also not an answer choice in this book. Sometimes Barron's is not good at picking good sucker punch answers, but anyway. So what you can do if you want to want me to prove that I'm right here, notice that the sine of angle A here would be the opposite over the hypotenuse, which is 6 over 10. And if you take the inverse sine of it, that's approximately 36.9 degrees. So this whole thing, this is 60 plus 36.9. That's going to be 96.9. That's bigger than a 90-degree angle. So we take the areas of both ABD. All right, well, this is easy. This is 6 times 8 divided by 2, so that's just going to be 48 divided by 2. That's 24. And this is going to be 8 root 3, so fine, we can multiply that by half. So that's going to be 4 root 3 times 8, so that's going to be 32 root 3. So fine, so we end up with 24 plus 32 root 3, which is choice D. Problem 13, page 576. Which of the following expresses a true relationship between x and y in the figure above? Well, all right, we can combine like terms. So we know 6x plus 3x is 9x. So we have 9x plus 9y equals 180. How do we know it's 180? Because it's a triangle and the degree measures always add up to 180. For the internal angles, anyway. So, if you don't know anything else about triangle geometry, please know that the angles add up to 180. So we get x plus y equals 20. How did we get that? We just divided everything by 9. So 180 over 9 is 20. So y is equal to 20 minus x, which is choice A. B is wrong because all we know is x plus y equals 20, so we don't know that y equals x. Could be, but we don't know. The trouble is if you have two variables and only one equation, which you have here, you can't solve for the variables. You have to have as many equations as you have variables to solve for it. C is wrong because x plus y equals 20, not 90, and D is wrong because 9y equals 180 minus 9x, not y equals 180 minus 9x. Problem 14. What is the perimeter of shaded triangle ABF? Well, here we must know our special right triangle side ratios. This problem is all about the triangle side ratios for these special right triangles. Luckily, there really are only 2 you need to know for the SAT, and they're the only ones they use here. So they tell you this side is 1, they can show you this is 30, 60, and since this is a corner of a rectangle, it has to be 90. So all of these corners have to be 90 degrees because it's a rectangle. So once you know that DE is equal to 1, then you know that the hypotenuse has to be equal to 2. And because of that, also, AD has to be root 3 because it goes 1, root 3, 2. So once you know that, then you can say, okay, this is 2. Hey, that's across from a 45-degree angle here. This is 2. That's also across from a 45. Oh, I get it. This is 45, 45, 90. And they even gave you a little box to let you know that. So I know if this is 2, this is also 2. And this has to be 2 root 2 we always know that 45, 45, 90 triangles have a 1, 1, root 2 side ratio to each other. So the hypotenuse is always root 2 if the side is 1. And when you have a different number, you just multiply. So since this is 2 root 2. All right, since EF is the hypotenuse of this other triangle here, EFC, whatever, then we know that if this is 2 and this is the hypotenuse of a 30, 60, 90, the shorter leg of the 30, 60, 90, FC has to be 1 and EC has to be root 3. So all of a sudden we know what AB is. We know that AB is root 3 plus 1. Why? Because it's got to be the same length as DC, which is 1 plus root 3. And then since this is root 3 and BF is, well, we don't know what BF is, but we know SC is 1. Again, we know since this is root 3, BC has to be root 3. And to find BF, all you have to do is subtract the length of SC from BC. So it's going to be root 3 minus 1. So the perimeter is just going to be root 3 minus 1 plus root 3 plus 1. Obviously the plus 1 and the minus 1 cancel out, so you have 2 root 3, and then you have 2 root 2. So it ends up being 2 root 2 plus 2 root 3, which is choice D. Problem 15. Questions 14 and 15 refer to the following figure. Okay, so this is the same one that we just looked at. What is the area of shaded triangle ABF? Well, okay, we know this is going to be 1/2 base times height. So the base is BF, and the height is AB. If you want to make AB the base and BF the height, it does not matter at all, but I usually like to make the taller one the height because it's called the height. So we know that the area is going to be 1/2 times root 3 plus 1 times root 3 minus 1. So by the difference of squares, we know that that just works out to root 3 squared, which is 3, and minus 1 squared, which is still 1. So it's just going to be minus 1. So that's half of 3 minus 1. We know 3 minus 1 is 2, so it's half of 2, which equals 1, which is choice B. All right, problem 16 is page 577. If the difference between the measures of two smaller angles of a right triangle is 20 degrees, what is the measure in degrees of the smallest angle? Now this one is best solved algebraically. So that's going to be x plus 20 plus 90 is just going to be 2x because we can combine like terms. Sorry, tripped over my own tongue a little bit there. Anyway, so we can see that 2x plus 20 plus 90 equals 180. Obviously, we can subtract 90 and 20 from 180, so we're going to end up with 2x equal to 70, and therefore x has to be 70 over 2, which equals 35. Okay. Problem 17. Questions 17 and 18 refer to the figure below. So, what is the perimeter of ABC? Well, alright, we can see that obviously angles DCE, or ECD, whatever you want to call it, and ACB are vertical angles because they meet at one point, so by definition they're congruent. And angles ABC and CDE are both right angles. We can see they're marked as right angles, so they have to be congruent. And if you have two angles that have the same measure in two different triangles, the triangles by definition have to be similar triangles because obviously if this is the same and this is the same, 180 minus these two here is going to be the same as 180 minus these two. So the third pair has to be congruent. The two triangles are thus similar. What that means is AB over DE, so 20 over 8 is going to be the same as CB over CD, so that's CB over CD, which is the same as AC over CE. So 20 over 8 equals 5 over 2. Since CD equals 15, then CB is going to be 5 halves times 15. So we're going to multiply this by 5 halves to get this, which is 75 over 2, or 37.5, as you can already see I wrote in my book. So, the next question is, okay, using the Pythagorean, still have to figure out the rest of this. So, using the Pythagorean theorem, we get 15 squared plus 8 squared is going to be equal to 64 plus 225, which is 289. 289 is 17 squared, so you take the square root of 289, get 17. Again, if you have your calculator, use your calculator. If not, hopefully you've memorized that, or you can at least guess at it. So, CB is equal to 5 halves of 17, so that's, you multiply 17 times 5 halves, you get 42.5, so the perimeter is going to be 42.5 plus 37.5, which adds up to 80, plus 20 is 100. So 18, what is the area of triangle ABC? Well, okay, we know that the base is 20 and the height is 37.5, 1/2 times 20 is 10, so you just end up with 37.5 times 10, which is 375. So there's your answer. Problem 19, page 577. Rihanna and Jason each drew a triangle. Both triangles have sides of length 10 and 20, and the length of the third side of each triangle is an integer. So, what is the greatest possible difference between the perimeters of the two triangles? Pretty easy. So if we assume the third side is the longest, the triangle inequality says the third side must be less than the sum of the two others, because otherwise it would be an open figure rather than a closed polygon known as a triangle. So the third side must be less than the sum of the two others, so the largest it can be is 20 plus 10, because these two sides, minus 1, since they all have to be integers, so it's going to be 30 minus 1 equals 29. Alright, so let's assume the third side is the shortest. The triangle inequality says the third side must be greater than the difference of the two others. So the smallest it can be is 20 minus 10, which would be 10 plus 1 equals 10 plus 1 is 11. Again, because it has to be an integer. So the difference between the greatest and smallest perimeters is 29 minus 11, which is equal to 18. Problem 20. If the measures of the angles of a triangle are in the ratio of 1 to 2 to 3, and the perimeter of the triangle is 30 plus 10 root 3, what is the length of the smallest side? The angle ratio can be expressed as 1x plus 2x plus 3x equals 180, so 6x is 180, therefore x has to be equal to 30. So the triangle is 30, 60, 90, and the side ratio is 1. Root 3, 2. So again, it goes 1, root 3, 2, just like any other 30, 60, 90 triangle. So side opposite the 30 degree is 1, side opposite the 60 degree is root 3, side opposite 90 is 2. It's easy to find that 1y plus 2y plus 3y, or plus root 3y equals 30 plus 10 root 3 for some value of y. Since we can see that 1 plus 2y makes 3y, 3y is going to be equal to 30, and 10 root 3 is going to be equal to y root 3, so if you divide through by root 3, then you quickly find out that y is equal to 10 from using either one of these equations. So the shortest side is y, which is 10. Did you find this video useful? I hope you did. Please like it and subscribe to this channel. Neither action costs you anything. You'll be alerted about my new videos. Why do I care? Well, it's simple. YouTube doesn't let me share any ad revenue unless I have 1,000 subscribers and 4,000 hours of view time in a year. While many people are watching these, I don't have 4,000 hours of watch time and I don't have anywhere near 1,000 subscribers. If you have a copyright issue, please contact me. I don't think I've used anybody's copyrighted material to the extent that it's not covered under fair use, but hey, if you've got a copyright issue or any other problem, please contact me. And for the same reasons, you're not only welcome but encouraged to share links to this video, put it in playlists, etc. And again, if you have a problem, contact me. I'm always happy to read and respond to constructive criticism or suggestions for new videos. Or if you don't understand something I said in a video, ask. If I'm wrong, I'll admit it. And if I'm not wrong, I'll explain to you why I'm not wrong. I'd appreciate your input. And hopefully you'll understand it better. Anyway, I reserve the right to delete comments from and block those who specialize in destructive criticism. Trolls, or things that are off topic, spammers, disturbed people. You can always contact me on my cell phone, which is 415-623-4251. You can text me if you like. Email is john@johnlinnebaugh.com. My mail, you can mail me at 1859 Powell Street, number 109, San Francisco, California, 94133. Thanks for watching. And if you need even more contact information, you can find my Facebook page for my business at www.facebook.com/Linnebaugh Tutoring. Instagram, it's instagram.com, again, / but it's john.linnebaugh.tutoring. And my phone number at my home office is 415-986-7355. My email is john@johnlinnebaugh.com, and my website is johnlinnebaugh.com. You can also go to johnlinnebaugh.tutoring.com. Either one will take you to the same site. All right, I hope you enjoyed this, and have a good day, night, or whatever time of day it is. Thanks, bye.